input output organizations. Okay. Okay, shall I start?
Yes, sir.
Fine. So basically in this unit, so we'll discuss the main concepts. So the important concepts in this unit are, the first one is the interfacing, and the next one is the asynchronous communication. So in that asynchronous communication, we'll have two things. So those are, the first one is asynchronous communication, how it is going on, and the next thing is what is a asynchronous serial transfer process. Okay, and the next, what are the different types of IO operations we can perform. Okay, and the last one is input output processor. Okay, so the first I'll start with the basics. So the input output organizations. Okay, so here in the input output organizations, basically everyone is having idea about the block diagram of computer, right? Okay, so in the block diagram of computer, the basic units which we will use are the input unit, output unit, and the processor, and the memory unit we have. You know this, isn't it? Is anyone out there?
Are listening, sir.
Okay, so these are the four typical units which we will use in the case of the computer. Fine. So the unit which will take the input from the outside world will be called as an input unit, and the unit which will display the output. Okay, so based on, after performing some kind of operations or computations, it will display the result to the outside world with the help of the output unit. Okay, and some units which can take both input and output. Okay, so here whatever the inputs we are using, either input unit, output unit, or the input output unit, those combinations. Okay, these all things will be considered as a peripheral devices. So the first, the important concept under this unit is the peripherals. So I am going to discuss about the peripherals. So the peripheral devices, so are the input output devices which we are using for giving the input or taking the output from the computer. So we know input peripherals, it is just like the keyboard and the mouse, those will be the input peripherals, and the output devices are the speaker and the display, this will be the output peripherals. And the input output peripherals are like the touch screen which we are going to use in your mobile phone. Okay, it is capable of both taking the input and giving the output to the user in the form of the screen. Okay, so the touch will act as an input and output peripheral. Fine. So when we are making use of this kind of the input and output peripherals, so the biggest problem is the input and output devices, means the peripherals will be designed in electromechanical. Okay, means, so if you take example as a keyboard, so the keyboard will have some mechanical function, like if you press the key it will bounce back. Okay, so that is the one of the feature of the keyboard, so one of the feature of the hardware device. Suppose if you take the touch screen, so it will work based on the some pressure. Okay, some real time scenarios we will consider when we are making use of the output devices or the input devices. So which all will be developed in the like electromechanical, uh, making use of electromechanical technology. And if you take example as our CPU, so the CPU is an electronic device. Okay, so it will not have any such kind of mechanical functions. Are you following?
Yes, sir, we are following.
Okay, so suppose if you take any input output device which is having the electromechanical feature, and the CPU which we are using will be having the, so it's an electronic device. Okay, that means it will perform the computations and it will process the data and it will give the result to the user, but it will not trigger any points. Okay, so these two are different things. Okay, So if you want to provide the communication between these two different things, okay, so with what? The one which is implemented in electronic circuits, so that means the CPU, and the one which is implemented in the electromechanical means the input and output, that means a peripheral device. If you want to provide the communication between these peripheral devices and the CPU, so we must require an interface. Do you understand what I am telling?
Yes, sir. Yes, sir.
We are having two things. The first one is the peripheral. The peripheral will be implemented in some electromechanical, and the electronic devices will have the different features. So these two cannot communicate with each other. Are you clear? Okay, so
Yes,
these
sir.
two
We are
cannot
listening, sir.
communicate with each other. So if you want to provide the communication between these two, okay, we must require the third person or the third party we require. Okay, so in that case, they can communicate with
Yes, sir.
the third one, which we are calling it as the interface.
Interface.
Yeah, the third one, which we are calling it as an interface. So here,
Interface.
yeah, I have an interface. The interface is used to provide the communication between the two units. The first one is the CPU, and the next one is the input-output devices. Fine. So the interface is a shared boundary between two separate components of the computer system. What are the two separate components? CPU and the input-output. Okay. So why we are making use of this CPU and the IO, and how the interface will understand these things, I'll explain in the next slide. Fine. So here I have some things need to discuss about the peripheral devices and the CPU and the interfaces, how they are interrelated. So the interface, whenever we are going to make use of the interface, which provides a method for transferring information between internal storage and the external devices. For example, input, we are giving it from the keyboard, and the CPU, which is implemented in electronic device, okay, that is processing data and it is giving it to the electromagnetic devices. When we are doing this stuff, we will consider the four things. So the first one is what type of peripherals we are using. So we are using peripherals as the electromechanical devices and the CPU with the electronic device. Okay, that's the first thing we need to consider. And next, what is the data transfer rate of the peripheral device and the CPU? When compared to the CPU, the peripheral device will have obviously less data transfer rates. Okay, the CPU will provide the high speed data transmission, but whereas in case of the peripherals, it will provide the low speed data transmission. Okay, and the next one, the peripherals always will transfer the data in the form of bytes, and the CPU will transfer the data in the form of words. Okay, so the peripheral will give the bytes information and the CPU will transfer the data in the form of words. For example, 64 words, okay, 32 words, 128 words, 256 words, like that it will transfer the data. When compared to the CPU, the peripheral will have the less speed, okay, and less data transfer rate. And the peripheral devices will work based on the asynchronous principles, and the CPU will be a synchronous. What is the synchronous and asynchronous? I'll tell you. The synchronous is the time based. Okay, the synchronous means clock based and the time based. For example, if you want to do any work, so within the 10 minutes you have to do that work. That will be called as the synchronous. Suppose if you take asynchronous, so it will not have any clock. Okay, so it will not have any clock. It will have only start and stop. You can start the work and you can finish once you reach the stop bit. So that will be then asynchronous. So when we are making use of an interface, the interface will be designed based on these four. So first one is the peripherals. Okay, second one is the data transfer rate, and the third one is how much data they are sending and in which mode we can operate. Are you following?
Yes, sir. Yes, sir.
So the data transfer rate and the unit of information, peripherals and the operating modes are the main things we will consider, and these four things so enforced to design the different interfacing devices. Fine.
Yes, sir. Yes, sir.
Okay. So next, so you like Do you know all these things, and what are the peripherals you can use, and what are the different data transfer methods, and each and everything you got to know. Okay, but how to make use of these interfaces? Is there any separate unit is available to connect to provide the connection between the CPU as well as the your keyboard or input output devices? Is there any separate unit is required? Okay, so that things I'll explain. So here basically we'll make use of the three kind of the buses. You know the buses.
No, sir.
You don't know the buses. So when you are transferring the data from the CPU and the other devices, we'll make use of some buses. Without the buses, you cannot transfer the data. Do you have any idea about the buses?
No, sir. Only slightly.
Okay, I'll tell you. Basically, we'll make use of the three types of the buses. So one is the data bus, and next one is the address bus, and next one is the control bus. Okay, so these three buses, without these three buses, you cannot move even single bit information from the CPU in and out. Okay, what are the three buses we have?
Control
Data
bus.
bus, address bus, control bus.
Data bus, address bus, and control bus. So the names we can clearly understand based on the names. So the data bus is used for transferring the data, and address bus is used for trying to identify the device address, and the control bus is used to provide the synchronization between the devices and the microprocessor. Are you clear?
Sir, we could not get the control bus, sir.
So the control bus basically you are making use of the input device and the CPU is there. Okay. Who will tell the microprocessor that it is an input device and this is an output device and you need to take the input and you need to provide the output? Some person should be there, isn't it?
Yes, sir.
Whether you are taking input and whether you are taking output and what you are trying to do. Okay. Or whether you are performing read operation or whether you are performing write operation. So who will monitor all these things? So that monitoring duty is the control bus. So the control bus will do this type of the activity. It is just like coordinating
Okay, sir.
between providing the coordination between the CPU and the different devices. Okay.
Yes, sir.
Okay. So now, are you able to see this bus organization?
Yes, sir.
What we have on the screen?
Processors, interface,
Processor,
data address control.
Processor and the data address control buses and the interface and some of the devices which we are using. Okay.
Yes, sir.
Yeah. Here you see. First I am explaining about the processor. We know the processor is the main part of the computer system which is used to perform the different tasks. Okay, and if the processor wants to perform any simple task, it requires the data bus, address bus, control bus. Fine.
Yes,
Now
sir.
I am making use of the four devices. One is an input device, keyboard, and one is a printer. What type of device?
Output.
device.
Output device and magnetic disk. What it is?
Magnetic disk. It is also an output device, no, sir, like a CD.
CD. You are not going to store any data. Magnetic tape and magnetic disk.
Okay, sir. It's an input device, sir.
It's an input device. So this magnetic disk and magnetic tape, so which we will consider as a both input and output devices, which will take the data and which will store the data, both. Okay, so you see,
Okay, sir.
one
Yes, sir.
thing I'll explain. So if you take the first one, so the interface, keyboard and terminal and the processor. So what you understand based on this? Interface, keyboard and terminal and interface. Interface is connected to
They
what?
are
You tell me first one. Interface is connected to what?
Interface is connected to 3 buses.
Three buses.
Yes, sir.
What are they?
Data, address, and control.
Data, address, and control. Okay, so the 3 buses. So we are going to connect one interface. Fine. And next, interface is connected to what again?
Interface is connected to processor, sir.
And directly it is connected to processor interface.
Uh,
The interface is directly connected to the buses, and the interface is directly connected to the input or
output devices.
Input output
Yes, sir.
devices.
So the basic role of the interface, it acts as an intermediate device between the buses and the peripherals.
Yes, sir.
Okay, and the duties performed by the interface are, the first one is it will try to identify the device address. So from which port we have connected. Okay, and the next one, what type of operation we can perform. So the keyboard, what type of operation it will perform?
Entering the data input.
It will take the input.
Yes, it will give the input.
Yes.
It will give the
Yes, sir.
input
Yes,
to
sir.
the microprocessor. So that is the type of
Yes, sir.
operation. Based on the device you are telling, it is used for giving the input. Okay, the type of operation it will identify. That is the second one. And next one. So it will send the signal to the peripheral controller. Means, suppose if I press any key on the keyboard, so it will understand, oh, the user is giving the input. Means that line will be activated. Are you following?
Yes,
Let us
sir.
say 1, 2, 3, 4 are there. So 4 devices I am connecting. I gave 1 to keyboard, 2 to the printer, 3 to magnetic disk, and 4 to magnetic tape. Okay. So if I press, if I want to give the information through the magnetic tape, what is the number?
4.
4.
So what it will understand? So the provide signals for the peripheral controller. From fourth line, they are trying to give some data. Okay.
Yes, sir.
So it will understand like that. So what is 4? 4 is here the device address. Okay. What type of the operation I am performing? They are trying to enter the data, means input. Okay. And based on this, it provides that line entire signal will get activated. So these 3 buses will be under control of the fourth line and they can send the data. And one thing you need to remember, at one time we can make use of one device. Simultaneously, we cannot use all the devices. Okay.
Okay, sir.
Let us say holding the keyboard key and dragging the mouse, and you want to click some icon. Will it work?
No, sir.
I am pressing some key and I am trying to do some operation with the mouse. So it will not work.
Yes,
Okay.
sir. It will not work.
So at the one time, so that line, concern line will get activated and it will take data from that. Okay. So the 4 main duties of the interface is what is the device address and what type of operation we are performing and which signal is activated and how to transfer the data between the CPU and the memory. So the interface will take care about these 4 things. Did you understand? And this is a 2 marks question.
Yes, sir.
So the 4 things are, what is the first one? The first one is the device address, and the second one is what? Type of operation, and the fourth one
Type
is
of operation.
and the fourth one is which line is activated, and the fifth one is how to transfer the data between the CPU and the memory.
Yes, sir.
Are you clear? And this is an 5 marks important questions, and the list out the different roles of the interface also will be a 2 marks question, and draw and the explain diagram for the interface unit. Okay. So communication and the bus timing we can tell. This concept is a IO bus communication with the different devices. Are you clear? You have any doubts in this?
No, sir.
Okay. And the next one is, so what are the possible commands the interface can issue? So the types of IO commands that are given by the processor. So when we are making use of this one, okay, the possible commands we can use are the four. The first one is the control commands. That means, what is the control commands? Providing the synchronization between the devices and the CPU. Okay, and the status commands. The status command is like whether the device is busy or whether the device is having any error. Okay, so that kind of requests or the responses will be monitored by using the status commands. What is the status? Okay, are you active, are you inactive? So that will be the status. In the same case, the device also will have either error or it is busy. Okay, and the next one, data output command. That means taking the data from the processor to the peripheral. Okay, that means CPU is giving the output, isn't it? Data output command. CPU is giving the
Yes, sir.
output, and input means we are going to give the input to the CPU. So the data is to be read from the peripheral device. That means the user is taking data from the input devices. So these are the four possible commands which we will use, okay, when we are dealing with the interface. What are the four commands we are using? First one is the
Control command,
control
Control.
command for what?
status commands, data output, data input command.
What is the use of control command?
Synchronization between
Ah,
output devices and the microprocessor.
and the next status commands are what?
To check the status, either the processor is buses are busy or not.
Buses are busy or buses is having any error. To check that kind of data, we are having the status command. And the next one is the data output command. Means taking the microprocessor is giving the data to the peripheral device. And the last one is the data input command. Okay, means taking the data from the input device. So these are the four commands which we will use. And here is the 2 marks question is, what are the different commands? What are the different input output commands the CPU will use when it is making use of the interfaces? Okay,
Yes, sir.
so the four possible commands are, we have status, control, status, data input and data output commands. Fine. So under interfaces, the questions you can expect from this concept are, the first one is the, okay, what is the difference between the computer and the peripheral devices? That means the CPU and the peripheral device. Okay, so this is the first one you can
Yes,
expect.
sir.
And the next one is the diagram. Okay, IO communication interface diagram. This is IO bus communication interface. Okay, so we are making use of the different buses, and the explanation you should give in this way. So the thing is, so the explanation, like the possible explanation we can give here. So the processor, and what is the processor is making use of the different things, the data bus, address bus and the control buses. Okay, and then different interfaces we are using and the connecting. Are you there?
Yes, sir. Yes, sir.
Okay, and the next one is the, what is the main role of the interface? Okay, so those are the four things we have, and the list out the major roles of the interface. So that is for the 2 marks. And the next one is what are the possible commands we can use? Okay, what are the possible commands we can use are issued by the processor? So those are the four possible commands which we are going to use. We know already this one. Okay, and these are the questions you can expect from this concept. So you have any doubts in this?
Yes, sir.
Hmm?
No, sir.
Shall I
Sir,
go
can
to
you
the
once
next?
explain the difference between peripheral and computer, sir?
So the main differences between the peripheral and the computer is, the first one is the implementation. Okay, so the electromechanical devices are the CPU peripherals, and the CPU is implemented in electronic device form. Simply, it is a electromechanical circuit and it is a electronic device, CPU. And the next one is the, when compared to the CPU, the peripherals will have the lesser data transmission rates. Why? Because so they are combination of both electronical functions and the mechanical functions. And the next, the peripherals will take the data in the form of bytes, and the CPU transfer rates are huge. Obviously, it will transfer the data in the form of words. Okay, word is a group of bytes. Again, it is a group of bytes. Okay, and the next one is the operating modes. So the like autonomous and asynchronous, and the CPU will be the running based on the clock. Okay,
Yes,
so those are the 4 differences between the CPU and the peripheral devices. So the main thing of your interface is, if you want to provide the communication between these devices, the interface will provide the communication between the peripherals and the CPU. Why? Because the two together, they two cannot communicate with each other. That's the reason we are going for the interfaces. Implementation is different, so they cannot communicate with each other. So we are making use of the interface.
okay.
Still, is it okay?
Yeah, sir, it's okay.
You don't have any doubts, right?
Yes, sir.
Input output organizations and the things we are going to use this input output and the input output peripherals, and this is about the basic, and the peripheral is nothing but the devices which we are going to give the input and take the input will be the peripherals. Okay, and the interface, we are possibly between the two things, CPU and the input output. Okay, and these are the possible ways which we can use, which will make use of the interfaces. Okay, and this is the diagram, and those are the different roles, and the possible commands which we are going to use here under the interface. Fine.
Yes, sir. Yes, sir.
Yeah. And I'll discuss tomorrow the memory mapped IO and the isolated IO. Okay, and peripheral IO. So the 3 topics I'll discuss tomorrow: peripheral and the memory mapped and the isolated IO. So if you have any doubts, like, you can ask me in this interfaces, and you can expect one long answer and one short answer from this interface.
Yeah, sir.
Any doubts? Nothing,
No,
right?
No, sir.
Fine.